It's about a 1 mile circuit of pipe in the street. It's a continuous loop, so you have a single pipe running a 1 mile loop. And we have about 140 customers connected up to it. That's a combination of single family residential homes, small and large businesses, as well as a number of low income apartment buildings that are all sharing that thermal resource. So in addition to the pipes in the street, we have service lines that run to each of the buildings and connect to the heat pumps that are providing that heating and cooling energy. And then we also have 3 separate bore fields that are distributed throughout the loop that provide the thermal energy to the water that we're circulating.
Welcome to Geothermal Unleashed, where we're going to explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. Joining me today is Eric Bosworth, the manager of clean technologies at Eversource, and he is located in Boston, Massachusetts. I'm pleased to welcome you to the show today, Eric, and let's get started with how about you giving us your background, of how you got into the geothermal space, and how you started working with Eversource.
No problem, and thanks so much for having me on today. My background, I am a chemical engineer by training, so went to school for engineering. Immediately afterwards, signed on as an international field engineer with an oil and gas company. So was shipped down to Mexico for a few years doing some land work, and then I spent about 5 years out of Norway in the North Sea, going out onto rigs and doing oil and gas service work. From there, I transitioned back to the United States and signed on with Eversource, a large utility in the Northeast, as a gas engineer. So I worked in the gas engineering department looking at risk analysis, pipe replacement, capital project type of work, but always kind of had that drive for working on new and interesting things. And so when the Clean Technologies department was created here at Eversource, I was the first engineer to put my hand up and say, hey, I'd love to be working on that. And it happened to be a great overlap with my previous skill set because one of the main initiatives we were looking at was utility scale geothermal networks. So ambient temperature loops combined with bore fields for the thermal supply. Having an oil and gas background, I understood drilling. I could read a well log. I could talk to the drillers. It was very, very similar to the previous work that I had done, just on a smaller scale.
Very interesting. Okay, so you started mentioning some terms. So the ambient loop. Can you just dive in to share a little bit about the project that has been done at Eversource in Framingham, Massachusetts?
Sure. I always like to take a step back first when I'm speaking about the geothermal work that we're doing here at
Okay.
Eversource and clarify geothermal can mean a lot of things to many different people. Some people think deep geothermal, hot rock for power generation. Others think direct use, warm water circulating through a neighborhood for heating only. What we're exploring and mainly focused on is actually shallow geothermal. So up to about 1,000-foot deep boreholes circulating water at mostly ambient temperature. So between, let's say, 40 degrees Fahrenheit and about 70 degrees Fahrenheit, and we couple it with heat pumps. So we are using the heat pumps to concentrate the heat in the winter, blow it out into homes, do the exact reverse in the summer to provide cooling, and the entire system acts like one big thermal battery. So it's a form of geothermal, but it is more for space conditioning and more of a utility style offering versus power generation or direct use.
Wonderful. So can you explain what the setup looks like? So you're heating and cooling just residential homes, or does that include commercial? And then how does the loop circulate around this area?
Sure. So in the case of our project, it is a loop that is providing energy to an entire neighborhood. It's about a 1 mile circuit of pipe in the street. It's a continuous loop. So you have a single pipe running a 1 mile loop. And we have about 140 customers connected up to it. That's a combination of single-family residential homes, small and large businesses, as well as a number of low-income apartment buildings that are all sharing that thermal resource. So in addition to the pipes in the street, we have service lines that run to each of the buildings and connect to the heat pumps that are providing that heating and cooling energy. And then we also have 3 separate bore fields that are distributed throughout the loop that provide the thermal energy to the water that we're circulating. You can think of it almost like a hydronic baseboard system in a home, where you have a furnace and you have a pump that is circulating water through the home and providing hot water to heat. We're doing the exact same thing, it's just that ambient temperature water. So we have a central pump house that pumps the water throughout the neighborhood, and then each of the customers, whenever they need energy, they will turn a small pump on in their home or business. It will exchange water with the main loop. They will run it through their heat pump, they'll pull heat out of it, the water comes back a little bit colder, and then continues the loop around till it hits the bore field, where it goes underground, exchanges energy with the bedrock, comes back out, and the circuit continues.
I'm curious, is this a unique setup, or are there other examples of a similar setup across the US?
So there have been a number of these projects, both across the US and the globe, actually. The technology itself, ground source heat pumps, are not new. People have been leveraging ground source heat pumps for individual buildings for decades at this point. We know the technology works. What is novel in this case is the deployment of a shared loop, and specifically a shared loop in the public right-of-way by a utility. Examples of other shared loops that have been done, there are university campuses that generally make very good candidates. They have great load diversity, they own all of the land, and so it's much more straightforward to put pipes into the ground, connect the buildings all up onto a shared system. And there have been some great examples of both energy and water savings, actually, from university style systems. But in our case, we were trying to answer the question of how do you provide this more broadly to the general public, to our utility customers? And you really need the utility involved to be able to put those pipes into the public right of way underneath the roads and connect up a bunch of private customers that otherwise would not be sharing energy.
So one of the questions, you may have just answered this, that I had that I wanted to ask next was, what was the primary goal of the project, and the objectives that you were trying to achieve? Was it doing this shared loop, or was it, I'll let you answer before I.
So the primary goal of the project was actually just to answer a lot of questions and gather data to inform whether or not this was a responsible service offering as a utility. The states that we operate here in the Northeast of the United States, we have strong decarbonization goals. And so as a utility, one of the things that Eversource wants to do is how do we provide our customers with options to meet those decarbonization initiatives? Networked geothermal or thermal energy networks, there's different verbiage depending on who you're speaking to, they seem to fit that bill reasonably well, and especially as a gas utility, the skill sets involved in deploying these systems are very, very similar to our traditional everyday work. And so the goals of the pilot were kind of twofold. One was to demonstrate that we, the utility, can deploy these systems. We can do it effectively. We know how to install them. We know how to operate them. But then also to gather the technical data on how much energy savings are there? How much emissions savings can we realize? Do the customers like the service? What were the home conversions like? And so we're trying to compile all of that data and inform the next project or the next iteration of this project, so that we can optimize, we can reduce costs, and we can provide better service to customers.
Okay. So implementing a project of this scale with so many consumers that are involved, doing something new, I'm sure there were many challenges to get this off the ground. Can you talk a little bit about what were some of the maybe technical and then just the overall deployment challenges that were faced?
Yeah, from a customer standpoint, it was a huge focus for us during deployment because while, as I said earlier, the technology itself is not new, we know ground source heat pumps work, this was a new iteration or a new deployment of the technology, and communicating clearly with the customers so that they understood what we were doing and why we were doing was absolutely critical. And we tried to take an approach of covering all bases there. We developed informational materials. We developed one-pagers, fact sheets, but then we also got out there in the community and actually talked to the customers. We knocked on their doors, we held community meetings, because if they don't understand it, they're not going to agree to participate. And so step one is really just providing that information and making the customers feel secure that we're here as the utility and we're going to be doing the right thing by them. And so whatever questions they had, I was there in person up at community meetings, fielding rapid fire questions. But at the end of the day, there wasn't anything that was left unanswered. And I think the customers came away with a much greater sense of ease about the project itself and a willingness to participate.
Yeah, that's excellent. That Eversource, I think, is a great example of community engagement. How much time was spent on community engagement leading up to the execution of the project?
I'd have a hard time putting a specific number on it, but it was quite a bit. And it wasn't just myself or my team that I work with. We really did leverage all of that expertise within the broader organization. So we had sales and marketing personnel that were cross-trained to work on geothermal. We had our communications folks that were helping. We had our media team, sort of the whole breadth of the experience that the utility does every day with electric, gas, water service was able to be very quickly cross-trained and redeployed on geothermal. And I think that that's what really paid dividends.
So was it just immediate acceptance from the local communities, or was there pushback? Could you talk a little bit about, if there was some resistance and how was that addressed?
I wouldn't say it was immediate acceptance. I think for the most part, customers approached it with curiosity and looking for more information. And that's what made that stage of the project so critical, was really answering all of their questions and making them feel secure about how the technology was going to work, how we were going to be deploying it. So it was definitely a process, and it was done over a number of months. As we were going through the initial design of the system, one of the questions we had to answer was, what's the load going to be? How many customers are actually going to participate? So in parallel, we were working closely with the community and the customers and the city of Framingham, that is the host community for the project, to really dial in on who would like to participate, who's willing to sign a letter of interest or a customer agreement. That way we can finalize the system design and we know exactly what we're purpose building it for, rather than going in with a nebulous, we may get 100%, we may get 20%, somewhere in between. We really had concrete numbers because we had those customer agreements in hand.
So at this point, do you have a handle on the carbon emission reduction from a system like this compared to your traditional heating and cooling methods?
So we have ballpark ideas. Admittedly, we are just going through the first heating season here of the system being online. So we're gathering that data daily at this point, looking at customer usage, bills, comparing it to previous usage, et cetera. But for the most part, if a customer is coming from traditional natural gas service, the number you can find out there is on the order of about a 60% emission savings with the current Massachusetts electric grid, because they are going to an electrification technology, but the grid itself is not fully renewable. So you're not eliminating all of those emissions. That's obviously higher if a customer is coming from propane or fuel oil, which is also very common in the region. And then if they're moving from electric resistance heat, which we had quite a bit of on our existing neighborhood as well, those savings are quite large, because you're going from a system with an efficiency of 1-to-1 on the electric resistance to a system with an efficiency of 1-to-4 or 5 in some cases. So you're having upwards of 75% savings in that case.
Okay, so the first phase is operational. What does a day now look like for you? What are you focused on? Are you operating the system? Are you collecting data?
Yeah, a typical day for me is admittedly all over the place.
Okay.
My responsibilities for the ongoing loop and system are kind of twofold. One is the day-to-day ensuring that the system is operating properly, making sure that the temperatures are in range, the pump speeds are in range, that we don't have any problems that need to be addressed. But also the second portion of that is the data collection. So making sure that we're gathering all of the relevant data, that we can look at customer usage and we're comparing month over month energy bills, and that we are, developing customer communications as well around all of this, because just because we turned the system on doesn't mean we walk away from the customers and stop communicating with them. We're making sure that they understand their bills and their usage, thermostat settings, how can you optimize and reduce energy consumption. So that's sort of one portion of my responsibilities these days. And then the other side of things is looking forward to the future, things like policy development, engagement with states and regulators and stakeholder groups. I do a lot of outreach and public communication and sharing lessons learned across the utility industry. So I find myself split between sort of the project itself and the ongoing efforts and work to have that go as well as what direction are we moving in and what does the future look like.
That's wonderful. So for this particular loop, are there any plans to expand it beyond the 140 residents, homes?
So we do have expansion plans currently. We actually jointly with the city of Framingham and HEAT, which is an NGO out of Cambridge, won a grant about 2 years ago at this point to design an expansion on the existing loop. So we used the DOE funding to go out and find an engineering firm that could look at the existing loop and then design the piping, look at the loads, look at the customer connections for essentially doubling the size of the existing project. So we would be going from about 375 tons of peak load for those familiar with HVAC sizing to about 800. So we would be a little more than doubling the capacity of the system and tacking on an additional neighborhood just to the west of the existing system. That work took place through last year, and we actually applied to the DOE for a down select round to fund the expansion work or partially fund the expansion work. And we're currently in negotiations right now, trying to finalize what that will look like.
So the first phase was also funded in full or in part by the DOE?
No, the first phase was funded entirely through a gas rate case. So we, the gas company, went to our regulators in Massachusetts and said we would like to demonstrate this technology. We put it into a rate case, and the Massachusetts Department of Public Utilities approved the project. So we are funding it via gas rates for the first iteration. On the second iteration, we would be offsetting costs as much as possible with grant money from the DOE and then constructing that way.
Interesting. Okay. And so, just out of curiosity, who would typically, like if we saw more of these types of loops going into neighborhoods, who does typically fund them up front?
It's almost a case by case basis. Admittedly, there's not a lot of data out there because we are the first utility to undertake a project like this. So in the public right of way, there's a lot of interest from gas utilities across the country that are looking. There's legislation that's been passed in states like New York that mandates the gas utilities explore this technology. But in other areas, it doesn't necessarily have to be. University campuses are another great example where the technology is really taking hold, and there are a number of them actively exploring it on their own. And so it kind of depends on where you are and what type of a system, whether it's a utility, a municipality, a university. All of them are kind of taking their own look, and there are multiple different ownership models that could potentially work.
Let's see. What has been the most surprising or unexpected finding since this project began?
I think the most surprising thing for me throughout the process of the whole project is just how widespread the support was for it. Admittedly, it's not often that you see a gas utility working closely with NGOs and stakeholders, as well as state agencies and a municipality, and everybody is running in the same direction together, working on something like this. There's been just an amazing amount of support across the board, and I've been very pleasantly surprised by that. There are very few people that come out and don't like geothermal, and generally when they don't like it, it's because they don't understand it.
So do you think that's one of the biggest challenges right now for more massive adoption of geothermal is just folks are not educated about geothermal?
Yeah, I think they're either not educated about it, they don't understand it, they haven't been exposed to it, or they have a preconceived notion about it from maybe individual building installations that they are then applying to this utility style offering that is not necessarily apples to apples. And so generally from my experience, if I have a chance to sit down and talk to somebody about it and explain the benefits, they come around.
Yeah, interesting. Okay, so my last question is, can you talk about any other future projects, geothermal projects that you're working on?
So nothing concrete at the moment. We did speak earlier about the expansion opportunity that we're exploring in Framingham. I'm actively looking for other opportunities within, our service territory and where we may be able to deploy loops. Admittedly, we're still working on regulatory and legislative frameworks. The challenging thing with geothermal is that because it's so new, many of the areas that we and other utilities operate in don't have established frameworks for utility ownership of these systems. And so working out the details on what that ownership model looks like, what rates look like, how we would be deploying these systems is extremely important. And that's what the pilot data is going to be informing. We're gathering pilot data, we're working on what the frameworks may look like, and then hopefully we can see additional projects coming in the near future.
Well, excellent, Eric. The work you're doing is very exciting. Very happy for the success that you've seen so far. And I want to thank you for joining me today. And I want to thank all of the listeners for joining us on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened your understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.